need his name up in lights. He just wants to be heard.
Yeah.
Hello, everyone. We are so excited to be here to talk about an Angular app. This Angular app was built for the iPad, and it was built on top of NativeScript. My name's Nathan Walker.
I'm Eduardo Speroni.
We worked together with a team of folks on this app, and it's called Blackout Lighting Console. It is a digital version of an analog console you might find in a theater production house. We wanted to bring the full experience of an analog console onto the iPad, and it communicates through the DMX protocol with connected lights. I want to give you some Angular-specific stats about this. So how many components, services, directives are actually in this? There's 114 components, 91 services, only 11 directives, and only 2 pipes. The reason for only 2 pipes is we prepare most of the data before we project it into the view. So we didn't need too many pipes in this app. All views are using Angular 17 control flow syntax. We were able to take advantage of this the day of release in December, and we were super excited to use it. And we did see some performance gains in converting a lot of the views. Let's talk about some unique Angular stats. This app is not perhaps maybe the typical Angular app. All Angular components are iOS UI kit, and we have some Swift UI views in here via NativeScript. In particular, 33 usages of Swift UI. 8 of them are unique Swift UI views, meaning all the others are instances of components we created. They're Angular components that represent Swift UI componentry. All input data is driven via the Angular data bindings you all know. Typical data binding syntax. All of the output events flow out of Swift UI through Angular component outputs and communicate with the entire system just as you're used to, through services and all interconnected components. Why use UIKit or Swift UI with Angular? We're Angular developers. We want to architect the core of this app with Angular. That's what we know to develop apps with. But we wanted to reflect the true iOS view characteristics. There was a lot of demands on this app in production and in the field. We needed all of the true iOS view characteristics at hand because we needed some pretty mission-critical view performance in this app. Also, open source availability. The iOS community has a pretty thriving open source community as well, and we found great Swift UI libraries that fit directly cases in this app. In particular, we wanted to take advantage of fundamental iOS features like Core MIDI, Foundation, and Core Graphics. This is an example of an advanced color mode. Everything you're looking at here from the color wheel on the left and the individual sliders are individual Swift UI components, and they're hooked up through the Angular architecture that surrounds it. In particular, this kind of looks like this. It's a Swift UI that identifies itself through its Swift UI ID. That Swift UI ID coloring is what that is. The data itself is hooked up through immutable data structures going through standard Angular inputs into Swift UI, and then all of the Swift UI events are coming back out, and this allows it to tie it to the entire system. So let's shift to my colleague here, Ed, to talk a little bit about virtualized lists and collection view and why they mattered in this app.
Yeah, so any app that you're going to do, at least on native side, you're going to use virtualized lists. That's kind of like the standard thing. Native apps actually don't handle well like lots of elements, especially like in scrolls, so that's a must, right? So here we have how they usually work on the web, which is you just have items, and then the viewport scrolls, and then what's up just slides down, and you have the same amount of items there. On native, though, it's a bit different. So usually you're going to have like multiple templates where sometimes you're going to show like an image, the other times you want to show some text. So in this scenario, imagine that you have like a list or of like alternating X and Y templates. So when you scroll, start scrolling, and then we store the template X, right, on a view pool, and this view is still there. It's just like detached from change detection, for example. And then we create a new template, so it spawns like a new component, new everything, and that gets slide under. So it's kind of keeps going and creates like view pools. So you always have to be careful, because even though your components are not showing, sometimes they're just like detached from change detection, but they're not destroyed. So view creation on native is very costly. And it's very sensible to layout changes. That's why I have to use these multiple templates. So we get the minimum amount of shifts into the view structure as we can. So stutters are also very perceptible. If you're using a native app and you start scrolling, it's going to, the stutters are, you notice it right away. So we usually use the visibility property from NativeScript, which allows us to, depending on how like we want to show that to be visible or hidden, right? There's also like collapse. So hidden would be just hidden from sight, and collapse would be, it would be collapse and also affect the layout. So let's go a bit into the change detection part of this, right? So we have a lot of things that are detached from change detection. So it is important that we do not run change detection on those items. We also don't you don't need to run like change detection on the items that are actually hidden by the visibility property. So we have a custom directive that we built, which is nsif. We use it like in some places in the app, as well with the control flow syntax. And what it does is it works just like the ngIf, but it avoids the view destruction that ngIf does. So it detaches the view from the change detection, and then it allows for you to set, so when the view is attached, what visibility do you want to show? So you want it hidden, so it's just hidden but still affects the layout, or you want it collapsed, so in a way that it doesn't like change the layout at all. So it works something like this. You have the condition, and when the condition is false, we detach from change detection, we apply the visibility to that node, and then we can even unload, which is a special NativeScript property, where essentially you pause all the native updates. So even if like some kind of like, rogue thing is running and tries to update a native property, that is not applied until it's loaded back in view.
So Ed, do you think in this kind of app, was strong state management absolutely necessary?
Oh, for sure. So before we get into that, let's do a quick DMX for Dummies, which is the protocol that we use to control all these lights. So DMX is not like a terrible protocol, like a super complicated one, but let's go to some basics. So a light fixture, so like this one, is a collection of parameters. So you have like your color, RGB, you have the intensity, you have pan, you have tilt, so they move around, right? And each parameter has an XY range, and they will map to like 1 or 2 DMX channels. So we have, for example, intensity goes from 0 to 100, so 0% to 100%, and will map to 1 or 2 DMX channel. And a DMX channel is just like 1 byte. So you have like a lot of DMX channels. Sometimes the value is going to be like 8-bit or 16-bit, so it maps to 1 or 2 DMX channels. So if you go intensity from 0 to 100, it can map to 0 to 255 and 0 to 55,000 and something. Yeah. So let's talk faders, right? You have seen this probably a lot. You use in audio, for example. You get the audio in, you put a volume, it modifies the input, and then you get the output, which is lower or higher volume. So there are many value sources, and the combined results with final 0 to 255. Faders will modify the input based on priority. So you have like faders stacked on top of each other, and faders can be the inputs of other faders. So essentially you have this stack thing, and every value you have in the app is a fader of a specific priority. So everything stacks. So let's give an example on Blackout. So we have a fixture. Let's calculate the intensity parameter. So the fixture starts at 0, then the fader 1, based on look 1, is at 25%, the final value is 12.5. Then fader 2 is non-additive, it replaces the value with 50 because the fader is at 50. But then the fader 3, as in sequence 2, is at 50%, acts on top of the previous one, the final value is 65. And then finally, you disable fader 2, and then now it has to act on top of the first fader, and the final value is like 46.25.
That's a lot of information, Ed. Let's back up. All of this information, do we really need to do all of this in the field? Is it absolutely necessary?
I mean, only if you want to have like nice things like this, so you tell me.
Okay.
Yeah, so strong state management is definitely needed for this app. You can have just like your lights just go out in a show, or you have like something happen and you reconnect it, and the state that you're in is different from the state that you were last in, right? So all the values are derived from the single source state, our source of truth. And one small change, so one fader that you change like a small value, can affect all the lights on the project. And this change cannot trigger recalculations on lights that it does not affect. So we do a lot of like NGRX optimizations for this. My personal rule of thumb is more selectors equals better. Like we can see on the example here that if we do select state, so I'm just like joining the people by the name, if we use the first selector, every time any state changes happen, that selector is going to run, and it's going to be essentially like an operation like changing that array, and that's costly, you know, that's something that you don't need. But if you use the second approach, where you first select the array and then you change it, then you join it, then it will only run if the people array actually change, right? So you use multiple small things, small selectors that do little work, and then you feed that into selectors that do the big work in a way that it's kind of like better to have the small work like eat up a bit of your processing than every time you do the heavy work, right? And we also use additional memorization inside the selector themselves, because sometimes it's not possible to do the selectors that you need. Sometimes you need like extra knowledge that you run inside of one selector. So you can use your own custom memorization techniques, or like a custom memorize method that just retains the identity. So the output, so even though you are running in a selector and you might not change everything, you're going to memorize your output because the outputs are memorized. And then you also have back pressure. So this is something that NGRX and a lot of like RxJS in general has, where there are multiple inputs. You can like drag a lot of faders up and down, and they'll probably give you more like state changes, more like than multiple times per second or multiple times per frame, and you don't want that. So every subscribe selector that you use, right, so async pipes, whatever you do on NGRX, and subscribe to that, it's going to trigger change detection on every state change, or like not change detection, but the whole selectors. So even if you discard those values later, you're still like eating up processing time. And the bounces and throttle, they will actually just work after the selector has already cost you like all those precious CPU cycles. There are a couple of ways that we can solve that. So the first one is actually to throttle before the selector. This is kind of like a little hack that you can do. And then this is going to prevent all the selectors from running, right? The other one is you can use some kind of like buffering, and this is something that we do. So when you change a fader, to send this data to the lights, we only need every 20 milliseconds or so. So what we do is we have a meta action, kind of, that the effect takes an action, buffers it, and then it dispatches one single action. So one single state change every 20 milliseconds instead of multiple. And the other thing that you can do is select signal. So this one is a very good one if you're like you just want to a quick way to optimize your apps right now is you can use select signal. As select signal, we only make the selectors reevaluate when change detection runs. So you don't have to worry about too many things going on there.
So this is a lot of data to put on the main UI thread. It's actually impossible to do all this on the main UI thread. So multi-threading was absolutely necessary to do in this app. And I guess what else could be going into the app that we would need to consider? Maybe another physical controller board?
Yeah. So if you go like to the booth there that they have like a setup with MIDI, right? So you have like MIDI setup. You have, and you can also have like multiple things going on. So you can have you're changing your UI a lot, right? So if you're changing your UI a lot, and let's say your UI hangs a bit, you don't want the lights to like the effects that you're playing to stop, right? So we use a worker for that, right? So you can use it's just like web workers.
Let's take an example from a user case here, just using the fader inputs. You can stop by the booth out in the corner and experience some of this yourself, but all that data that's going through the app and updating the list in real time, a lot of multi-threading is happening there to get the data out to the lights while taking in all that pressure of data coming in.
Yeah, so let's talk a bit about the workers and the data transmission. So DMX, it needs a constant like 44 Hertz transmission rate. That's like the standard. Your app needs to be transmitting like that. And one of the reasons is it's an UDP protocol. So everyone knows like UDP is kind of like you throw something in the air and maybe someone catches, maybe someone doesn't. So yeah, that's kind of like how it works. So you have to consider that like some light might just like skip a few packages. So you have to be on a constant rate. And the other thing that's very important is, let's say your light had a connection issue, or you just connected it to your network. Then you want it to go to the state that it's programmed to be in at that exact moment. And if you're not constantly transmitting, it's just going to go to the default state and do nothing. And of course, if you're like on a show and you see like, let's say you see the beams going on the crowd and the beams stutter midway, that's not going to be a good look as well. So you need this transmission. And that's how we also use workers for effects in a clever way that you can also use on a few places where you can have workers inside of workers. So you can run the effects completely detached from the UI, but also detached from the worker that transmit the data. So we calculate these values on the UI thread, all like the selectors run, and then we put in a shared array buffer. I'm not sure if you ever heard of a shared array buffer, but it allows you to send, essentially write data on the UI thread, and then a worker also has access to that same data. And then the effects run on the nested worker, right? And the nice thing about NativeScript is NativeScript will get this shared array buffer, and it will, when you have to call the C API, it's going to marshal it in a zero copy mode. So essentially, what's in a shared array? What's an array buffer? It's just an allocated memory, right? So you can just use, and what usually the C libraries are going to pick is just allocated memory that you send to the light. So NativeScript will just send the same like pointer to that data, so you don't need any kind of like copying from like one to the other. Yeah, so the data is transmitted to Art-Net and sACN, which are the C libraries that I'm talking about, and we call that directly from JavaScript. There is like, we can just call like dmx.send, which just calls like directly the C library, and we get the data in. Yeah, and we have like the zero copy from things. And also, for example, it also works for other structures. So NativeScript also marshals, for example, if you pass like JavaScript arrays, you can get like a JavaScript array, and like let's say it's an array of numbers, and you send it to an iOS function that receives an NS array. So the NS array is like also an array like of ints or whatever. The way that NativeScript does it is it creates an adapter. So this adapter does is like when the iOS side requests, oh, I want like element 5 of the NS array, it's going to go into the JavaScript. So it enters the isolate on the like V8 side, is going to get that number specifically, and then return to the native world. So nothing is being copied, and you get like very performant code.
So we're lucky to have the product owner actually with us today, and we're going to welcome Jeff Brink, out here to the stage. Jeff Brink came in from New York late last night, and if he doesn't, the front of the stage is right there, Jeff. Okay. We're gonna try something here live for you all, and we're gonna try to control these two DMX lights using everything that we were talking about here from the Vision Pro. And you can see what he's seeing. So this is the blackout interface here, and he's enabled the hand tracking by opening pan and tilt, and looks like we have operation. So, nice job, Jeff. Are they actually going in the direction of your finger?
Yeah.
Up.
Yeah, and this is actually
Down.
just like casually Angular running on the Vision Pro, like that was out like a couple of months ago. So
Yeah, so this is the same app that's running on the iPad. It is running natively in Vision OS, and so the hand tracking provider that is in the iOS framework is being used here, and it's just mapping the value in the same way that we're mapping the value from all the state selectors in and out to the lights. We're doing the same with the hand tracking provider and running those to translate to pan and tilt. Nice job, Jeff. Thank you.
yeah.
And so again, thank you all for hanging around this late in the day. My name is Nathan Walker,
I'm Eduardo Speroni.
and Angular
Can light up
anything.